This video will focus on how to round your calculated answers when you use measured numbers in order to calculate something. Essentially in chemistry class, because we're dealing with measured numbers, if you do a calculation using those measured numbers, you must take into account the precision of the equipment when it comes to rounding. So again, we don't say like, just round to the hundredths. We actually consider the precision of the measurement and then round it. So the rule up there in red is the rule for rounding. You must record your answer to the same precision as the original measurements. Okay. So how I go about doing this is I use all my measured numbers in my calculations, just like I normally would. Just plug them into my calculator and solve. But then that final answer, to figure out how to round it, I go back to all my measured values and I determine how precise they are. Okay, so what I mean by precision in this case is how many measured values they have or how many significant figures. So I give you some examples up here. If I measured something to be 6.55 grams, that has 3 measured values, the 6, the 5, and the 5. If I measure something less than 1, like 0.9943, the 0 in front doesn't count. It can be there, it cannot be there, so it's just the 9943, so that's 4 measured values. And then 52, right, the 5 and the 2, that's just 2 measured values. So again, I take my measured values, I calculate like I normally would, then I go back to the numbers I used and figure out how many significant digits they have. Then I round my final answer in order to reflect precision by the least precise measurement. So essentially, the least precise measurement limits my ability to report further digits. So for example, with this very grainy example, if I was dealing with an object that I massed out to be only 16 grams and I did the volume to be 37.7 mils, I would plug that in my calculator, I get some absurd number that's giving me precision down to, like a very small fraction. And then the 16, right, only has 2 measured digits, and that 37.7 has 3, so I'd have to round my final answer just for 2. So to figure out which 2 is essentially, you're just rounding, right? So I need to show the 4 and the 2, and then all the rest I just drop in this case. When it comes to calculations, and we'll kind of talk about this as they come up, you do not have to consider the precision of things like standards. Standards are like 60 seconds per 1 minute. Constants, the speed of light. Counted objects, there are 16 pencils. That's not considered measured then in terms of precision. Conversion factors, so we'll use something called molar mass a lot, and you won't have to worry about sig figs for that. And then any other non-measured number. So essentially, we're only doing the sig fig thing based on measurement, which means you have to constantly be considering like what's measured and what's not, and to what degree of precision those numbers are presented at. So a couple of other examples, okay, if I was trying to find the surface area, 47 and 63.1, to get area, I'd multiply them, and then I'd look back at my numbers, figure out how to round. So 47 only has 2 sig figs, 63.1 has 3, so I'd round my final answer to 2 based on my least precise value. Right, so if I plug that in my calculator, I get the 6495.7 thing, but I can't show that degree of precision because of that 47. So to round that to just 2 significant figures would be 2, 5, and then replace the other values with zeros. Okay, if you're rounding that to like 1 sig fig, it'd be like around 2,000. Next example, I'm going to find the density, which is mass per volume. Take my mass in grams divided by the volume in mils. Get my final answer in my calculator, and then the gram calculation has, or measured value has 3 sig figs, the volume one has 4, so I round my final answer just on 3. Okay, so you can see when I divide them this time, I get this decimal point, and so the question always is, well, if I'm going to show three measured values, where do those measured values start? Those zeros in front aren't considered measured, they're considered place values. You need them there in order to get to your number, but there's no value there to record, so they're not considered measured. So your first measured value then is the 393, that's 3 of them, and that's all you'd report. Okay, so one of the difficulties here, and you can see it in these 2 examples, people often get tripped up on zeros, and we'll practice them more. There's something called a leading zero, which is like when you have a number less than 1, and those leading zeros are not considered measured. And then trailing zeros, zeros that need to be there in order to keep your value, right? 25 is much different than 2,500, but they aren't considered measured because you have no actual value there. That's it. Why don't you go ahead and try the quiz, and have a nice day.